Hello friends, today we are going to learn digital storage oscilloscope, how to use the digital storage oscilloscope. What are this? These are different pins and different switches are there. So what are these switches are and how to use DSO, that we'll learn, and we'll test the signal of this motherboard. Suppose a laptop is no display and if you want to find a problem with the help of DSO, then which are the signal that will check with the help of oscilloscope. So this is the on off switch. So first we have to turn on. So I just turn on this oscilloscope. Then here it will give one cursor. So this is a attend digital storage oscilloscope and this line is called the cursor. Okay. So this is the cursor and here is mentioned CH1. CH1 means channel 1. So this is called the probe. Okay. And this is a BNC connector. So we can connect like this. Let's connect like this, and this is a probe. This crocodile clips is called a crocodile clips, and this is a positive, like in a multimeter, positive and negative, something like that. This section will call a negative and this section is called the positive. And this channel is on 1 volt. So this is a channel 1. These are two channel, like if this is channel 1 and this is channel 2. Okay, this blue line is a channel 2. This blue line is a channel 2, you can see here, and this yellow line is a channel 1. So now we are testing only one channel. So what I'll do is I'll switch off this channel, and channel 1 only is operations. The channel 1 is there because I have only one probe. So channel 1 we are using, and channel 1 is on 1 volt. This is a voltage line. So if you want to change the voltage, then we have to use this knob. So like just I changing, see, I can changing this knobs, and here are changes. So now it's gone on 10 volt. So I have to change like this. Now it's a 5 volt. Then now it's 1 volt. Then 500 millivolt. Then 200 millivolt. Then 100 millivolt. And then 50 millivolt is like that. So these are the voltage line. Suppose if I keep on this on 1 volt, and then this cursor, this is my grid, and this is on the center, that is a 0 volt. And if this cursor is moved to here, that means this one house is a 1 volt, another house is a 1 volt. So like every house is a 1 volt. See, suppose if I keep this knob on a 2 volt, then one house will be 2 volt. Each house will be 2 volt. Suppose if I keep here on a 5 volt, then each house will be 5 volt. If the cursor moves to the up, then that voltage will be the positive voltage, and if cursor goes down, then that the voltage will be a negative voltage. Okay, so it's like that. So now I'll keep on 1 volt only. So now it's a 1 volt, and how to test we'll see. So first we'll see any voltages. Okay, so I have this battery or in my hand, and suppose one probe I connect to here, negative probe, and positive here, then it will move like this. See, it's gone up to 3 houses. So the cursor is here, then it will move to 1, 2 and 3. You can see here. Okay, so and showing here the maximum voltage is 3.4 volt and the minimum voltage is a 3.6 volt here. And if I check this battery in a reverse, like if I connect negative probe at positive point and negative to the positive, then the cursor will go down. You can see here, see the cursor gone down like this. So its cursor gone down to the 3 houses, that means, and it's showing a 3.3 volt over here. So in this way we can check the voltage like this. If the cursor goes up, then the positive voltage, and if the cursor goes down, that means the negative voltage. And how much voltage will be there, that is depend on where we keep channel. If channel 1, then each house will be 1 volt. If we keep channel 1 on 2 volt, then each house will be 2 volt, like that. So this is the voltage. Okay, now we'll see the frequency. So here this button is for the frequency. This button is a frequency, and it will show on the time. Here it is showing 500 microsecond. You can see here when I'm moving this, then the time it changes. 250 microsecond, 100 microsecond, 50 microsecond, 25 microsecond. So I'm increasing the frequency. 5 microsecond, 2.5 microsecond, 1 microsecond, 500 nanosecond. It's like that. So time is changing. It's called the time. and this is a frequency. And when we're going to check all the parameter at that time, it will show here all the patterns of different frequencies, and it will shows here a different whatever the voltages are there and the frequencies there and the time is there will show on this line. Okay, this button is called the trigger line. When we want to lock the frequency, at that time we have to move this trigger line. Okay, and this is for the entire for the channel 1, this is for the channel 2, this is for the frequency. Okay, this button for the brightness, this button for the set as a default, this button for the checking this parameters, like measuring all the parameters. If you don't know anything, then if you want to see something, then we have to press this auto button is there. When we press the auto button, then automatically it detect all the parameters and signal and shown on the screen. And if you want to lock the screen, suppose some patterns appear on the screen, and if you want to lock that parameter, then we have to press this run button. At that time the parameter will be locked on the screen. Okay, so the next thing is here in the oscilloscope there is a mention, there is a 2 clips are there that mention there 1 kilohertz. Okay, and this line is called the testing line. Suppose if I want to see whether this my oscilloscope is working or not, for that I have to connect this oscilloscope here like this. I have to lock this, I have to connect this ground probe over here, and then I have to connect like this, and now it will show the frequency. It will show the frequency. So the frequency is mentioned here 1 kilohertz. That means the 1 kilohertz sending from here, and that same 1 kilohertz we are measuring on the oscilloscope. Okay, so here you can see these are the square wave frequencies showing on your screen, and then all their parameters are explaining here. So like the frequency is 1 kilohertz. Okay, the time is 1 millisecond, and how much the voltage. Now we kept on 1 volt, and that house is shifting to the 3 volt. That means 1, 2 and 3. That means the maximum peak voltage will be a 3 volt. So it's showing a 3 volt over here. Okay, so like that. Now if you want to lock the screen, then we have to press this simple the stop button, and then the red light will appear and the screen will be locked. And now if you remove this probe also, then the parameter will remain on the screen. Okay, it's like that. And now we'll see what is the auto button. So now we'll release this, and now we'll press this auto button. I press auto button. It takes some few seconds to settle the parameters, and see now when I press the auto button, then all the parameters appear. It's showing the frequency. The frequency is 1 kilohertz. VPP, peak to peak, from here peak, this bottom peak to upper peak, voltage will be 3 volt. Then time will be 1 millisecond, and the average voltage will be 1.48 second. Okay, so these are the parameters are showing. And if you want to see the detail, then we can click here. All the falling edge and rising edge will be shown in this screen. So this is a rising edge, and this is called the falling edge of this frequency. Okay, so in this way these are some buttons so for testing the signal. So now what we'll do is we'll check this motherboard. We'll see the crystals, the clock signal, then the frame signal, then the bias activity of this motherboard with the help of oscilloscope. Okay, so let's start. So checking the crystal, what we have to do is we have to keep this button into 10x. Okay, so here is one switch, 1x and 10x. So we have to keep this switch at 10x. Then we have to remove this, and we have to keep voltage at 50 millivolt for testing crystals. So I kept my oscilloscope on 50 millivolt. So in this motherboard there are 2 crystals. One is a 32.7 kilohertz, that is for the RTC real-time clock, and another is a 25 megahertz for the clock section. So first we'll check a 32.7 kilohertz frequency, that is the RTC crystal. It will show on the screen, and then after pressing a power button, there another crystal will start, that is a 25 megahertz. So first we'll check 32.7 kilohertz crystal. So for that we have to connect this probe to the ground, and another probe. The crystal is here, so I lock it like this, and I'll check like this. Check now, check, crystal, and it will show that crystal is there, and it will show our frequency. Okay, turn on the motherboard. You can see here that its frequency is showing. Now the amplitude is very less and the frequency is showing something 3.8. So to increase the amplitude we have to decrease the voltage. So I'll decrease the voltage. I'll keep it on 20 millivolt. And if you want to see this properly, or the frequency should be properly, then we have to move this button, so it will show a frequency. And if you want to lock, then you have to lock like this. Okay, so this is called the RTC clock or the RTC crystal. Okay, so next thing we will see the 25 megahertz crystal after pressing a power button. So we'll see where is this crystal is. This crystal is here. 25 megahertz crystal is here, which generate a clock, and that will check with the help of oscilloscope. For that we have to turn on the laptop. Your laptop is turned on. So now we turn on this motherboard, and I already told you there is a 25 megahertz crystal, and we connect our oscilloscope to the 25 megahertz crystals, and here it is showing a frequency that is 25 megahertz. If this 25 megahertz is coming, that means the clock section is working. Okay, so first we check this at the crystal. Now we'll see all the signal on the SIO, that is a LPC clock, and then we'll see frame and the bias activity. So let's start. Here is a circuit diagram for the same, and this is my SIO, and this port is called the LPC port. You can see here the mentioned LPC ports, and LPC port, this signal is called the CLK, stand for clock, LPC clock, and this signal generated by the PCH is called LPC clock, and this LPC clock is coming, that means the clock section is working. So this is very important signal. After checking the crystal, then we have to check this signal LPC clock on the SIO. So we'll check on the pin number 12 on this chip SIO. Okay, so here is my SIO, and we are going to check this signal on pin number 12. So here we are connected on pin number 12, then we are going to turn on, and then here will show a frequency, the clock frequency. The board is turned on, and you can see here 24 megahertz showing here, this LPC clock. Okay, this clock supposed to generate, that means the entire clock section is working. If the clock is not work, then in that case this is our SoC, that is system on chip, that means the CPU and the PCH is a combined. So if the clock will not come, then first we have to replace the crystal, and if the still problem not solved, then we have to heat the SoC or the CPU, and if still problem not solved, then we have to replace the CPU. It's like that. But here in this board the clock is coming. So the next signal we are going to check that the bias activity. This is called the SPI bias. 8 number pin bias is there, and pin number 1 is a chip select, and pin number 2 is a read. This 2 pin is important for us. So first we locate the bias. Where is the bias? So here is the bias. How to locate the bias? The bias number start from 25, and bias is little bit fat than the MOSFET. So here is my bias, 8 leg bias. Pin number 1 and pin number 2 we have to check. Okay, so let's check. So this is your bias SPI ROM. Number is W25Q64. 25 stand for bias, W is for win bond, and then 64. The size 64 megabits, that means this bias capacity is 8 megabytes. Pin number 1 is a chip select, pin number 2 is a read, pin number 5 is a clock, and pin number 6 is a write pin. Pin number 4 is a ground, and pin number 8 is a supply of this bias. So pin number 1 and pin number 1, that is CS, stand for chip select, and DO, that means data output, that means the read data goes to the CPU. That signal we are going to check. So we are connect oscilloscope to the bias. We kept pin into X into 1, and oscilloscope into channel 1. Oscilloscope in channel 1, and the switch into 1, and then once you press the power button, then here will be some activity. You can see these activities, signals going and coming. Some it's a vibrating signal. If this vibrating signals are coming, that means the CPU accessing the bias. Okay, so the next pin number 2, that is a read pin. How the data flows from bias to the CPU, that we'll see. So we connect, turn on, then you can see these are the activities. Signal comes and goes, vibrating signal, oscillations coming and going. This vibration is coming, that means the bias sending the data to the CPU. Okay, so this is the bias is responding. The next signal we are going to check, that is the frame signal. The frame signal we can check on the SIO. So for that we have to go to the schematic diagram, come to the SIO page, and we'll see on the LPC port, LPC frame. So here is the LPC ports, and this pin is called LPC frame, pin number 4. Here some vibrating signal will come, that means the CPU bias are communicating with each other. The bias is asserting, bias is generating the signal. Okay, so that will check. You have to keep oscilloscope on default 1 volt and then connect a pin to the SIO frame signal and then turn on the laptop. It will show that this cursor will move to the 3 volt and it will show some activity. See this activity. This activity appear, that means the CPU is responding. Okay, so in this way we use the oscilloscope to test all the signal. Okay, so for the no display, normally for the dead laptop, no need oscilloscope. For the no display, we can use oscilloscope to test all the signal, like to check the clock, frame, bias activity, and the display signal, RAM activity. All these things signal we can check with the help of oscilloscope.